Alright, let's talk about Uranus. No, not that kind of talk, this is a family-friendly channel. I'm talking about the planet Uranus. Specifically, why this ice giant is basically rolling around the sun on its side like a knocked-over bowling ball. And no, we still don't have a definitive answer. But the mystery? It's way more fascinating than the punchline you're expecting. So, Uranus has an axial tilt of 97.77 degrees. Let that sink in. That's almost perfectly sideways. If Earth was an upright spinning top, Uranus is a wheel wobbling along the ground. The go-to explanation? A massive collision billions of years ago with some rogue planetary body the size of Earth. But here's the thing, when scientists say most likely caused by an impact, they're basically saying this seems like the best guess, but we're not holding our breath for a confession. Let me unpack this. The giant impact theory makes sense on paper. The early solar system was a cosmic demolition derby, planets smacking into each other, moons being born from debris. Earth's moon probably came from one of these crashes. So why not Uranus? But here's what bugs me, when you hit a planet sideways, you'd expect chaos, molten rock, scattered moons, maybe even a different composition in the rings. Yet Uranus's moons and rings all orbit neatly along that same tilted plane. It's like the whole system leaned together. If it was a hit and run, the culprit left 0 skid marks. And then there's the magnetic field. Tilted 60 degrees and off-center. That's weird, right? If the planet was knocked sideways, why isn't the magnetic field pointing in the direction of the impact? This is where the single collision story starts creaking. It explains the tilt but not the lopsided magnetosphere. So maybe the real villain here isn't a dramatic crash but something slower, more insidious. Like a missing moon. Yeah, you heard me. A 2022 study suggested a moon, long gone, could have tugged Uranus into its tilt over millions of years. Imagine a tiny satellite playing tug-of-war with an entire planet, gradually dragging it sideways until, boom, the moon collides with Uranus and vanishes. Talk about a toxic relationship. But here's the kicker, both theories have holes. The impact model needs a debris disk that magically forms moons and scrambles the planet's interior to explain why Uranus is colder than Neptune. The lost moon idea requires a gravitational dance so precise it feels like planetary choreography. Neither leaves evidence we can 100% trace back. And that's what I love about this mystery, it's humbling. We think planets are these predictable spheres, but they're actually drama queens with hidden backstories. Oh, and let's not forget the seasons. A single solstice on Uranus means 21 years of polar night, 21 years of baking sunlight. The rings tilt open, the atmosphere changes, and the poles glow like giant streetlights. Voyager 2 saw just one season in 1986. It's like visiting Paris in winter and claiming you've seen it all. We're barely scratching the ice crust here. So where does this leave us? Uranus is a cosmic enigma wrapped in a sideways spin. The collision story is sexy, it's got drama, destruction, a before and after. But the universe isn't obligated to give us clean plots. Maybe Uranus didn't get knocked over so much as slowly pirouetted into its tilt through gravitational nudges. Maybe the real answer is even weirder. And honestly, I hope we never solve it completely. Some mysteries are more fun when they linger. What do you think? Smash that comment button and let me know, giant impact, lost moon, or something we haven't even imagined yet. Either way, keep looking up.